We've all seen the definition of a derivative as a limit, right? That's just the limit as h approaches 0 of f of x plus h minus f of x over h. But why is this? And also, is that the only way we can do a derivative? If I draw a picture of this, say I have some function, I got a x value, I'm going to move over to a distance of h, so this is x plus h. This kind of draws a picture of exactly what's going on, where this is f of x plus h, and this is f of x. So if I find change in y over change in x, I get this difference quotient. But what if I did it differently? What if instead of going from a to x plus h, what if you went from, say, from x to a? Well, I could do the same thing. I could take instead the limit as x approaches a of f of x minus f of a divided by x minus a. That's just change in y over change in x. That's another definition of a derivative. But wait, is there another way? Well, in fact, we could do it an infinite number of ways. What if instead of saying I go from x to a or x plus h, what if I say I go from x to, say, bx, where if b is equal to 1, these two are the same? Well, I could do the limit as b approaches 1, because that would make these two values the same, of f of the second point minus f of the first point, all over the difference, bx minus x. You know what? That's a third method we could use for the derivative. In fact, any method you want to come up with, it doesn't really matter, as long as you're going from one point to the next and the limit moves those two closer and closer together, like how b goes to 1 or a goes to x or h goes to 0. Any of those ways, and there's others as well, would work to calculate the derivative as a limit. If you like this video, be sure to subscribe to the channel. That way you don't miss out on any more helpful tips.